Okay, so I have a triangle here. However, this is not a real triangle. These lengths, 6, 4, and 11, it's not possible to construct a triangle with these lengths. Now, if you look at these lengths, they seem somewhat reasonable, but why is this not a real triangle? Well, this has to deal with a very important property of triangles, and a lot of people either don't remember learning this, have not ever learned it, or simply, just forgot this. But this is a cool little simple property of triangles that all math students need to know. But if you know the reason why this is not a real triangle, put that into the comment section. I'll show you the reason, and then you're going to learn a very interesting property and not difficult property, by the way, about triangles. Now, let me make a little kind of clarify something here. A lot of you might be thinking, is this the Pythagorean theorem? Well, no, I'm not saying that this is a right triangle. So if you're thinking a squared plus b squared is equal to c squared, well, that has nothing to do, generally speaking, with what I'm going to be talking about. Okay, so this is not a Pythagorean theorem type of situation. In other words, we're not talking about a right triangle here, right? We're talking about all triangles. So just a little bit of a hint and try to kind of build this up. This is a very cool property. Of course, I'll explain this in just one second. But before we get started, let me quickly introduce myself. My name is John. I have been teaching middle and high school math for decades, and it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so why is this not a real triangle? It certainly looks like a real triangle, but it is not. And the reason it's not is because of the triangle inequality. Now, that doesn't mean much. I'm kind of like, all right, it's a triangle inequality. And some of you are like, well, I don't even know what that is. What does that mean? Well, I'm going to explain this here in a second. But if you're like, yes, I knew it was the triangle inequality, well, we must give you a nice little happy face and A plus a 100% and multiple stars. You can brag to your friends and family that indeed you are a professional expert about the properties of triangles. Okay, triangles obviously are it's a very common shape. It is a polygon, a three-sided polygon, but there is so much that you need to know about triangles, and there's all different sorts of triangles. There's right triangles. It's just a big topic. You wouldn't think that a simple little shape would have so many cool things to learn about it, but it does. And what we're going to be talking about here is something called the triangle inequality. Okay, so let's go ahead and take a look at this. And let's take a look at an actual real triangle. Okay, now I did mention right triangles, and a right triangle is a triangle where one of the angles is a 90-degree angle, and it's indicated by this little box like this. So hopefully, you're like, yes, I know what that is, Mr. YouTube Math Man. I've seen these around. Well, this is an actual real triangle. Okay, this is a right triangle, but I want to kind of illustrate this triangle inequality. Okay, so the lengths of this particular triangle is 3, 4, and 5, 5 being the hypotenuse, and 3 and 4 being the legs. So when you have an actual triangle, here is a property that will always hold true. If you add up any two sides of the triangle, the sum of that number, okay, the sum is going to be greater than the other side. Okay, and this is the case for all combinations here. So for example, if I go 5 and 4, okay, 5 plus 4, is that greater than 3? Yes. Okay, this will always be the case in an actual triangle. Let's go ahead and check all these combinations. Is 5 and 3 greater than 4? Yep, 5 plus 3, that's greater than 4. And let's go ahead and check our last combination here, 3 and 4 or 4 plus 3, is that greater than 5? Yes, it is. When you have this situation, this kind of passes the triangle inequality test. So this is a real triangle. Okay, you have to meet these conditions. And of course, a lot of you are like, oh, well, now maybe I know why. our example, the problem is not a real triangle. So let's go and take a look at that now. But before we do, I want you to take a look at this subscribe button that you're looking at and think about this for like maybe 1 microsecond before you subscribe and hit that notification button. This goes a long way for me on YouTube. And, if you like my content, this just motivates me to make more, to try to help all of you out there that want to learn mathematics. Okay, back to the problem. Okay, so the triangle inequality. So all we have to do here is just kind of test the combinations, right? So let's test 11 and 4. So is 11 plus 4 greater than 6? Well, it is, right? Not a problem there. So we're good with that combination. Now let's test 11 plus 16. Okay, so 11 plus 16 is definitely going to be greater than 4. No problem there. But what about this situation? 6 plus 4, is that greater than 11? Well, no, it's not, right? 6 plus 4 is 10. That's not greater than 11. So this is not possible. This is not a real triangle. So even though I kind of made it connect, you're like, well, it looks like a real triangle. Well, really what we have here is this kind of scenario, right? So let me kind of just show you. As a matter of fact, we'll take a look at a new problem, or I'll kind of make something up to make this obvious. Let's say I had a length of 2, and then I had another length of, oh, let's say 5, and then I had another length of, I don't know, let's say 15, okay? Could we make a triangle with these 3 lengths? Well, let's suppose they were like straws or little sticks like this. You'd say, okay, well, let me see. How can I do this? Maybe I can get my 15 length right there. And then I got my little 2 right here. And then I have my 5. I'm like, well, I'm having a problem kind of constructing a triangle. Okay, I can't close this in because there's all this stuff, other stuff kind of, left here, right? I have kind of like an arrow. This is not a triangle. You might be saying, well, this part's a triangle. Well, yes, we have to close in, all 3 sides. The definition of a triangle is a 3-sided polygon. In other words, all 3 sides meet at a vertex, right? So we can't make that happen. And let's take a look at, y here for a second. Of course, we would have 15 here, 2 here, and 5 here. And you could see, obviously, that 2 plus 5, 7 is not greater than 15. We just can never make this work. But this is an illustration of the triangle inequality. And of course, I kind of exaggerated this scenario for this particular example. But these type of problems come up in geometry, especially on tests like the SAT, ACT. This is something that you definitely want to know. Not that difficult, but again, triangles is a huge topic in mathematics, okay? Not only in geometry, okay, but right triangles are kind of the foundation of trigonometry, right triangle trigonometry, and then that, of course, gets into stuff like pre-calculus and calculus. I could just go on and on and on, but I need to stop myself because I get too excited when it comes to mathematics. So if you need assistance with geometry, I'm going to leave a link to my full geometry course in the description as well. But I do have a ton of different videos on my YouTube channel covering all things mathematics, geometry included. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.